Great. Okay, so welcome again to Julia Gender Inclusive's Learn Julia with Us. This is our second meetup which we've titled Your First Julia Code, where we really jump into the basic fundamental building blocks of the Julia language and also talk a little bit about core programming concepts that will follow us throughout the workshop series and throughout your coding journey. So I just mentioned that we have this new meetup page, Julia Gender Inclusive, and we have a repository there called Learn Julia, where we have our materials. And I want to start off, so this first code.jl document is a Pluto notebook, and we talked a little about Pluto last time, but I want to make sure that we all know how to access Pluto. So if you open your Julia console, which for me looks like these three Julia dots. And yeah, then you get to your main Julia console and you need to have the Pluto package installed. So if you don't have Pluto installed yet, you need to go to the package manager, which you do by pressing the right square bracket. You can't see it here. Yeah, it would look like this bracket key. And then you can go to the package manager and add Pluto to your Julia installation and press enter. And if you've done that already, then you have Pluto installed and you can do using Pluto. And in case you don't know, Pluto is like a environment, or it's kind of like Jupyter Notebooks, if you're familiar with that, which allows you to have code and text right next to each other in your browser and actively see how your code changes the output. Okay, so run using Pluto, and then you run the command pluto.run with open and close parentheses. And this should open in my browser. Pluto is not the fastest thing ever, but it will open in my browser when he's ready. Okay. So when you run that, you should get to this Pluto landing page. And from here, you can open the file that we're going to be working on today, actually easily by putting the URL from our GitHub repo right in this text box. So you would take it from so if you go to like the page that we're using here, and you get the URL, you can take that and put it in the Pluto, put it in here. Okay, so I have this on my computer, so I can also find it from path, and I know where this is located on my computer, so I can type it from memory, but you could also check in your files. I have it in Documents, GitHub, Learn Julia, and it's this first code. So I'm going to open it from that just so that I have it in my file system, but you can use either one. So let us know in the chat if you haven't been able to open the file, or if you're lost somewhere on those instructions on how to get to the Pluto page. And I'll just let this run for a second. Are there any questions while we let Pluto get loaded?
No questions yet. I put the link in the chat. So if you've opened Pluto, you can just copy paste that and click open, and then that should hopefully work, and let us know if there are any issues.
Mm-hmm. Great. Yeah, that's one of the advantages to, oops, I have it open in two places here. That's one of the advantages to Pluto, is that you can open things right from GitHub and you don't have to save it onto your hard drive. But if you do save it onto your hard drive, that allows you to kind of save the progress. Like if you make any changes, it will save to where it was. I may have broken it here by having two open at the same time, but let's just
okay, hold on.
Start it again. Okie dokie. Julia, will you mute the person who's unmuted right now? Okay, so once you get it loaded, you will see our document that we're going to work from today. So, and before we get into it, I want to talk about some of the things that we talked about last time. So Pluto as a developing environment. If you were with us last time, you may remember that in Pluto, you work in these little cells, which can be either text or code, and you can intersperse text and code, which is why we're using them for teaching, because it's great to have like a little explanation and then have some code that you can play with and automatically see what changes that makes. So just in general, Pluto, you can press these little plus signs to add code cells. And originally they're going to assume that what you're typing in here is valid Julia code. So it's going to interpret this as a code that Julia needs to evaluate and spit out the answer to. And when it does that, the answer is always going to come above the code cell. But you can also do text in these boxes, which is an easy change. You just start with the letters MD, which stands for markdown. And you start and end quotes. And then within the quotes, you can write text. When you evaluate that, it will pop up just as plain text. It doesn't think that this is a Julia code that it needs to execute. So that way you can use, you can put comments, for example. And if you don't want to see the source of that, you just want to see the text, then you can hide using this little eyeball icon, you can hide the code that created this output or this text. Okay, so you can also delete cells. For example, I'll delete this one. And that's how this entire document is made. So if you see the code from this header line, you can see that I've written it in the markdown style, and I have indicated with a hashtag, which is the markdown convention, that this is a top level header. So you can always look at kind of the code that's behind each of these little blocks. Alrighty, and so today we're going to be talking through some materials that we learned partially from the first week of Julia programming for nervous beginners on juliaacademy.com, and also from the first part of a blog article by Logan and Kilpatrick on Free Code Camp, which was about learning Julia. So that's kind of what we used as our inspiration for this lesson. Are there any questions before I keep going?
No questions so far.
Okay, good. So let's talk about variables. Variables are one of the key programming units that allow you to work in an iterative way, and also to give your code structure and to continually name and reuse values throughout like a longer stretch of code. So these can be thought of kind of as data containers, like a container that has a label on it, and then you can put some sort of output into it, whether that's a number, or it could be a string of letters, it could be a true false value, or a couple of other things. And when we talk about variables, we talk about defining them. That's when we create them for the very first time. We define the variable by assigning a name to a value. So we can give the variable any name and any valid value. There are some restrictions, for example, on the names. In Julia, a name of a variable has to start with a letter. It can't start with a number, it can't start with a special symbol, it has to start with a letter. This includes all the letters, for example, used in English, as well as a few other letters. But if you use an English letter, you can be pretty sure that that's going to work. And the best practice in Julia is considered to be to use only lowercase letters and numbers in your variable name with no underscores or capitals. So for example, we've chosen a name here of our variable. You can see it starts with a letter. It's all in lowercase and there's no symbols in it. There could be symbols though, or there could be numbers. As you see, we could name it our variable 2. And so this is the name of the variable, then which comes on the left-hand side, and it's assigned to its value with an equal sign. So for example, we can give the variable, our variable, the value of 4 by setting our variable equals 4. Pretty simple. And the equals here has a special name. It's called an operator. And this is basically a special kind of function that isn't a single character. So the equals in Julia is considered to be the assignment operator because it assigns the value to the name of a variable. So with our variable, then the name is our variable. The assignment operator equals assigns that name to the value of 4. So our variable is equal to 4. And we could do this again. So for example, our variable 2 is equal to 5. This is also a valid variable name because it has a number at the end. It's okay if it includes numbers, it just can't be the very first symbol. So now we've stored these values and given them names. We can use those names to call those values. So for example, if we called our variable +3, that would give us an output of 7 because Julia knows that the value of our variable is 4, and 4 + 3 is 7. And same, we could add up 2 variables. So our variable plus our variable 2 would be 4 + 5, and that equals 9. And something kind of cool and a little bit different about Pluto is if you change a cell, it's going to change all the other cells that depend on it. So for example, if I change our variable to 40 and I run this, you can see it instantly updated our variable +3 to 43 and our variable plus our variable 2 to 45. And that's the same if you change any variable. So if I made this one 500, you'd see that our variable 2 plus our variable updated to 540. That's something specific to Pluto. That's not specific to Julia in other environments. Well, I guess Julia in other environments, if you change a variable, it will update the lines below it. But in Pluto, it will update any other cell that depends on that cell. You can also, so with variables, you can also build them on top of each other, so to speak. So you could make a new variable called our new variable and assign it to the value of our variable +1. So here, because the current value of our variable is 40, that would make our new variable 41. And kind of conveniently, you can define several variables at once. This can be convenient if your code outputs more than one thing, or you're just trying to make more than one at once. I would say if you have no reason to, I would still prefer the style of doing them on separate lines, but there are times when it can be really convenient to define them in this way. So for example, fave number 1 and fave number 2 are 2 names assigned to the 2 values 12 and 27. To where fave number is now 12 and fave number 2 is 27. So if we do fave number 2 minus fave number, we get 15. And again, so these are also updatable, and you can see if I change 1, it changes what depends on it. Let's put that back to 27. Okay, so far we've looked at variables that are numeric. So all these are assigned to a value, which is just a number, but that's not the only option that we have in Julia. And if we want to know what type, so that would be called a type. These variables are all of numeric type, these values. And if we don't know what type a variable is, we have a function called type of, which will let us know what type that variable has. So we'll see a few examples so you can get a feel for the different types that Julia uses. This won't be all that you hear about types. So understanding the types of Julia will take a little bit of experience or a little bit of time, but the basic and easier to understand ones we'll go over now. Okay, so we can use the type of function. And the type of function takes one argument as the input and it returns the type of whatever you fed it. So for example, a variable, or you could give it just a value. And in contrast to some other programming language, Julia is dynamically typed. So you don't have to ever specify, you don't have to say this 41 here is a number, but Julia will know or make its best guess that 41 is probably a number, and you probably don't just want the characters of 4 and 1, but you probably mean the number 41. So if we run type of on our variable, then what we get back is this int64, which is maybe not totally intuitive, because you might think, okay, if this is a numeric, this is a number, why is it returning int64? And what does that stand for? Hold on one sec. We can put this loud person in the reading room. Okay. Yeah. Okay, so this int64, what does that mean? Int stands for integer. So Julia differentiates between integers and numbers that might have a decimal point after them. So full integer numbers, counting numbers. And 64 has to do with the amount of storage space that it takes up on your computer. So it takes up 64 bits to store this number. And so in contrast to the integer, again, our variable is currently, I believe, 40. Then if you look for the type of a number with a decimal, like 4.52, you're going to get the output of float. And a float is just what Julia calls, so it's a floating point number, which is a number with a decimal point or like a partial, a fraction. So you can have integers and floats. And you can also have strings, which would be like a text string. Here I've used hello. That's pretty common to a lot of programming languages, but a type that's a little bit less common is char, which stands for character. So Julia differentiates between strings that have multiple characters and single characters. And if you noticed here, the strings actually take double quotes, while as the characters take single quotes. So these are not interchangeable. Like in some languages, you can interchange these. If you have experience with those, it might seem weird to you that if you type, for example, hello in single quotes, Julia's going to complain at you because the character type can only take a single character. So it can only take one of the letters. It won't accept more than one letter or character. Whereas a string is basically, you can think of it as like a text, just as text. Exactly. And then, yeah, one point is that you call, so the correct term for things like these double and single quotes are delimiters. And this is because they delimit the object. So they tell Julia where it starts and ends. It shows Julia the limits of the object. Now, something cool about Julia is that you can even use emojis as variable names. I can't think of a single reason why this would be practical, but it is kind of fun. And so to get these emojis, what you do is you type a backslash and then a colon, and then you start to type the name. I have to do it in a new cell, but backslash colon, and you start to type the name, and then you can press tab to tab complete. Oh, apparently I got slot machine. And these are the names of the emojis. Oops. And this is actually a good point. For some reason in Pluto, if you just type this and press enter, you get this error that you can't use it. But what you need to do is press tab, find the thing that you want. So here, I guess I want slot machine. And then you press tab again, and that will turn it into the icon. I don't even think I knew there was a slot machine emoji. So you can use emojis as variable names. So we could make this one equal to the string money, money, money. In theory. Okay, so here I have, for example, this watermelon. This watermelon is equal to 3. And then you can actually do the same types of operations with emoji named variables that you could do with properly named variables. So I can make a new variable and give it the name of this sort of woman looking face and set it equal to the value of watermelon times 10. And Julia will fetch the value of watermelon, which is 3, and multiply that by 10 and return the value of woman equals 30. And similarly, you can type Greek letters into Julia as variable names, also mathematical symbols, kind of overlaps, and characters from other languages. And for this, you need to know kind of what it's called in LaTeX. But for example, this is the alpha. So you can do the same thing, backslash, start typing it, and press tab to have it auto change into the symbol. Oops. Can be a little bit fussy, but basically if you press tab once or twice and you get these symbols. So this is useful in a lot of mathematical programming because you can use the symbols that would refer to that value in a mathematical equation right in your code. Okay, so we've looked a little bit about types, and I want to talk a little bit about why types are important. And part of that is because there are certain actions or functions in Julia that will be different, have a different action depending on the type of the object. So I want to show you for an example this asterisk operator. So if you do an asterisk between two integers, so 112 asterisk 47, then it will output the multiplicative product. So 112 times 47. So that's 5,264. You can also do this with named variables because again, Julia just treats them like as if they're the integers that they represent. So our variable times our variable 2, which I believe have the value of 40 and 500 where we left them off, which leaves us with 20,000. This also works with floats. So you can multiply 4.27 by 1.32. And similarly, you have other operators that work the same way as you would imagine them in your math textbooks. So 10,928 plus 4 returns 10,932. Okay, so that's what the asterisk and the plus sign do for numbers. But for strings and characters, the asterisk has a whole totally different behavior. And specifically, it's called the concatenator. So if you have hi there, asterisk, friends, then what Julia will do is combine these together into one string. So now it's returned one string, hi there, friends, delimited by the double quotes. But you see it's all together inside the delimiters. It's no longer two strings. Interestingly, this also works for characters. So if you have A asterisk B, it will also return one string with the two characters inside of it, A times B, A and B. And you can even concatenate strings to characters. So you could concatenate, which just means add together, good morning with G, the character G, and Julia would concatenate this into good morning. So you can see that Julia identifies that these are not numbers and doesn't try to do some sort of multiplication on them, but it uses the asterisk as a multiplication operator for numbers and as a concatenation operator for strings. So it knows that it needs to have a different action based on the objects that you give it. So just another example, you could do this with variables. So if you had the variable greeting and you assigned it to the string howdy, and you had the variable guest and you assigned it to the string Madam President, then I don't know if this is an E on the end. Okay. Then if you did greeting asterisk guest, you would return the string howdy, Madam President. Whether or not I've spelled that correctly is for you to decide. And then there's some operations or functions that won't work at all on objects of certain types. So we saw that the plus sign works to add two numbers together. But if you put the plus sign between two strings, you're going to get an error in Julia because the plus sign is not a concatenation operator. And in fact, it has no method for strings. So you'll see you get this error called method error, no method matching for the objects of type string. So that won't work at all. Whereas the asterisks, of course, as we've seen many times, will work, but the plus has no method associated with it for strings because there is no way to add two strings together. You can only concatenate them, and in Julia, you concatenate them with the asterisk. Okay, so we'll have time for questions, and there's a couple of little exercises that you can try out just to ensure that you have understanding of what we've just covered about variables and variable types. So I'll give you a few minutes to look at that and to think of any questions you might have, and then we have a little bit more on error messages after that. Okay, so I'll go over the answers to the exercises slowly. I hope you had enough time. And there'll be a few more exercises later for you to try some more as well. So the first one was make a variable called name and assign it to your name. So we can give the name name, and the value can be your name. That's Kyla. And we can run this. And it says, what type is this? So perhaps you already noticed from the double quotations as delimiters here that this is probably a string, but if we weren't sure, we could always check with type of, and we could put the name of the variable, which is name, and it will return the type. So I mentioned here, you can only have one line of code in each Pluto box. I don't think I mentioned that before today, but you can't. So for example, if I tried here to write type of name, it's not going to be really happy with me because you can't have multiple expressions in one cell. So by one line, what I really mean is one expression. If this was like a very, very long string that wrapped onto 2 lines, which I'll do here by just copy pasting my name, that's totally fine. You just can't have more than one like thing you're trying to do. So more than one function or more than one, what would be called an expression. So if we go back to looking at how this would look with 2 lines in one cell, this will actually give you a pretty good solution. So you can split the cell into 2 cells. And if you click that, Pluto will actually go ahead and help you out with that. And you have the option to wrap it in a begin end block, which is basically making like it kind of just groups a couple lines together and packages it together as one expression. Okay, but I don't think we need that. I think we just need 2 lines, one that defines the variable name and one that checks the type of the variable. Okay, number 2 says to make a variable called guest and assign it to the number of guests you would want to invite to a pizza party. How many guests would I want to invite to a pizza party? Like, maybe I want kind of an intimate pizza party, so I only want 6 people at my party. Multiple definitions of guests. Oops, that's because I actually have guests defined here, and Pluto doesn't want me to overrun that, so I'm going to name it guests. And give that the value of 6. But it was nice that Pluto let me know about that because I didn't realize that I had guest and guests going in the same document. Okay, so I've given that a value of 6. Now I'll make a variable called pizzas and assign it to the number of pizzas you'd have to invite. I'm thinking maybe we're gonna order like maybe 8 pizzas, you know, just so that everybody has their tastes met. 8 pizzas. And then you can calculate how much pizza each person would get by dividing the number of pizzas by the number of guests. So we could have pizzas divided by guests. And we see everybody gets 1 1/3 pizza at my very generous pizza party. Yeah, so then there's also this little bonus line that if you go back to exercise 1 and add a semicolon at the end of the line, what does that do? And I mostly just wanted to show off that if you add a semicolon, this will suppress the output. So if I don't have it there, then Julia will output the same. So for defining a variable, it will output the whole expression. But here, for example, type of name, it outputs the type. And if I put the semicolon at the end, it's actually going to suppress that output. So for some reason, I didn't want to show the output of that line. I just wanted to have that value be saved. Then I could have a semicolon at the end. You might see it a lot on variable definition just because it kind of cleans up the code a little bit to not see it twice. But that's what the semicolon does. Were there any questions on the exercises before we go on to the next little section?
No, I don't see any questions.
Okay. Okay, so now we're going to talk about error messages, because I really think when you start learning programming language, then learning to read and decode the error messages is one of the most crucial things you can do. So it's really good to start really early, being comfortable with making mistakes and with reading error messages and trying to get as much information out of them as you can. So I've shown a couple of error messages here. This block is out of place. So you can see what they kind of look like. So we have this one where I've tried to assign the value of hello to the name of my variable 3. But Julia has complained and printed out this error message, which says syntax. So we know it's a syntax error, which means I've typed something wrong or something that's not a valid Julia expression. And it specifically says there's an invalid assignment location close to the string hello. So invalid assignment location, we can kind of figure out what that means. We know that we are trying to assign a name to a variable here, and something about the location is wrong. And so when we remember that variables have to be defined with the name on the left and the value on the right, then we can probably figure out what's wrong here, which is that the name was on the right and the value was on the left. So if we correct this and put the name on the left and the value on the right and run it again, then you can see that resolves that error. And you can also notice that the code cells that have an error in them have this red bar, kind of light red bar on the side here, compared to those that are fine. They get this kind of gray bar. Yeah, I'm not sure if that's colorblind friendly. I have a feeling it's not, but this one is gray and this one is red. Here we have what's pretty obviously an error, that we just have equals my variable 3. That's not really any, so Julia doesn't really know what to do with that. It knows it's a syntax error with an unexpected equal sign, but it can't really guess what you were trying to do. Yeah, so we could correct that. We actually can't define my variable 3 twice in the same document, but we could define my variable 4 in the correct like syntax, and then that will resolve that error. But you could see that both of those errors that we had there were syntax errors, which lets you know that you've either done a typo or misremembered something about the code that you've tried to type in, and that you've typed something that's not a valid Julia expression, so Julia doesn't know how you want it to evaluate that. We can also get this argument error, which is a similar thing. So we looked at type of in the lines above for returning the type of an object. But type of takes one argument. So up here we had type of the variable name, or we had type of this expression hello, or 4.52. And if you try to run that without any argument, it's going to give you this argument error, which tells you there's too few arguments and it expected 1. So that's pretty straightforward. It wants one argument to come inside the function. It wants something to come in here. So you could have my variable 3 here, for example, to fix this. You just need to tell it what it needs to evaluate, what it needs to find the type of. And then there might be things you have not seen before that the error message could try to help you figure out. So I'm trying to look at this function that we haven't looked at yet called length. And I'm trying to take the length of this. I'm trying to look at the length of Kyla and Julia. And it tells me I'm missing a comma or a parentheses in the list. So here, if I try, for example, adding a comma between the two objects, I don't know if that's going to work. That doesn't work. You can try a couple of other things. So it's telling me that I might want to look at just one string. But we're going to look at the length argument in a little bit. So basically the point here is just to get really familiar with looking at the error messages, reading them calmly, and trying to figure out what's the most information you could extract from that and what might you want to try. And one thing that's really useful when you're working in Pluto is they have these live docs. And these will pull up the documentation of any function that you type about. So the last one I typed was length. So we can do that. It's not the fastest thing ever. But so if you start, you don't have to type up here, you can. But if you start typing in a cell code, you actually can also it'll automatically start typing in the live docs if you have the live docs open. I wouldn't leave the live docs open always because it seems to be very slow, but this is very handy. It pulls up all the documentation about the length function. So if we were trying to fix this error, we could look in the length documentation and see some examples. So we see the example of some numbers. So here we have 1:5, or we have these square brackets of 1, 2, 3, 4, returning the value of 4. And it gives you some examples. So it looks like it can return how many numbers are in a list if it's included in these square brackets with commas. It can return the number of characters in a string. So it's really good to get familiar with the documentation and to try to figure out what you look through to find what you're looking for. So it gives an example here of a string returning the value of 5 because there's 5 letters in Julia. So we might gather from that that we could maybe put these 2 strings in a list. And then kind of how we saw these numbers being done, maybe that will work. That returns the value of 2 because there's 2 items in there. But basically, if you pull up the documentation, you can get some ideas and look at the examples to get some ideas on how you might have the syntax incorrect in your expression or what the function does if you don't know. So we could have also looked, for example, at type of. Okay. Type of. So it tells you the concrete type, so you can get just some examples, which is basically what we've seen already. And I also want to look at this new function called uppercase first. So say we had come across the function uppercase first, and we didn't know what that did. We could easily type it into just an empty cell in Pluto with the live docs open, and it will pull up the documentation for uppercase first. So we could see it wants an input that is a string. An abstract string means anything string-like, and it will return a string. So the function uppercase first takes a string as an input and returns string as an output. Returns the string, here named S, with the first character converted to uppercase, technically title case for Unicode. And so it shows you if you do uppercase first with the string Python, it will return a string with a capitalized P in Python. And it also tells you that there's some similar functions here like lowercase first, uppercase, lowercase, or title case. So that's pretty useful and it allows you to quickly look up a function that you don't know or maybe quickly solve an error. But if you leave it open all the time, your Pluto is going to get very slow. So I would recommend you close it when you're not using it and only open it when you need to look at something. Okay, now I have a couple of more exercises about looking at error messages, because of course, looking at error messages yourself is the best way to get some experience looking at error messages. And so I'll give you a few minutes to look at those. Let us know if you have any questions, and also put in the chat when you're done with the exercises so I can go over them. Okay, so in the interest of time, since we're getting already close to time, and Julia also has things to show you today, I just want to go over the exercises pretty quickly here. So the first one is to use the live docs to figure out what this caret operator does. Let's find that on my keyboard. So if I type that into Pluto with the live docs open, it should pull up the documentation for the caret. And you see it's the exponentiation operator. So it will exponentiate. We'll take the value, second value as the exponent and the first value as the base, and exponentiate the base. And you can guess what this might do with the string, but it might be better to like scroll down a little bit in the documentation and see if you're correct. So it gives the example that if you exponentiate where the first value that you give it is a string or a character, so either a string or a character, and the second value you give it is an integer, then it's going to repeat the string or character n times where n is the integer. So let's try this out. So if we did 4 to the power of 2, or 4 caret 2, we're going to get 4 to the power of 2, which is 16. And if we try this out on a string, like Julia to the power of 2, or Julia caret 2, I guess I should say, you'll see this repeats the string Julia with no additional space or anything in there 2 times. So that's another example of an operator that has a different action that happens based on the type of the argument that you give it. And then here we have find the errors and correct them to make valid Julia expressions. This one says it's a syntax error where 1 is not a valid function argument name. We're really not trying to work with a function here, but we know that a variable in Julia has to start with a character, it can't start with a number. So this is reminding us that it's a syntax error to start a variable name with a number. So we can correct that by removing the number, or we could put the number later on in the string. It doesn't have to be at the end, as long as it's not the first character. We could put it right in the middle if we want, as long as it's not the first character. Okay. This one is an argument error, similar to what we saw above, that there are too many arguments fed to type of, and it only expected 1. So I've tried to give it hello and hi. So we can fix this by only giving it 1, or by combining the 2 strings into just one object, which we can do with a list, which is a type we haven't looked at, but we will look at in the future. But we did see it in the live docs, this option to wrap more than one thing in these square brackets with commas. And then we can see what that actually is a vector full of strings. So as long as it's only one thing. If the list is a bit confusing, then an easy way to fix it is just to give it only one string. This is an undefined variable error. And you might think, okay, we already defined my variable too, but I've just misspelled it here. So if you misspell it, you might get an undefined variable error. Oh, actually, we didn't have this variable. Our variable was our variable. So basically, it's just telling you that this variable doesn't exist. So you have to replace it with the type of variable that you've already defined. And finally, I've tried our new function here, this uppercase first, and I've tried to give it this input, which is just a C delimited by single quotes. And you can see we get a method error. There's no method for the function uppercase first, given just a character. So it won't try and make a character uppercase. So to fix this, we have to give it an argument that it does know what to do with, that there is a method for, and for uppercase first, we saw that this is really only strings. So we could give it the string C, and that will actually work. It just doesn't want to work with a character type, or we could have given it a longer C, like if we gave it the string cat, then we could see that it just uppercase the first letter. Yeah, are there any questions before Julia shows you about a little bit about working with error messages outside of Pluto?
I don't see any questions, so I guess that means I'll take over. Thank you, Kyla, and I'll share my screen. Okay, so Kyla was working, let me show you on GitHub actually. Kyla was working in this file, first code JL, this Pluto notebook. And actually, I'll move over to script_1JL. and I'll work in VS Code, Visual Studio Code. So we've seen these Pluto notebooks and that they're really nice looking documents, especially if you have a lot of text, and it's really good for teaching and for presenting results and so on. But people also often use scripts in an IDE, so integrated developer environment, which is something like VS Code, Visual Studio Code. That's what I'm using here. There are others. The one that I'm familiar with and really like working in is VS Code. If you haven't installed VS Code yet, I'd recommend that you go do that, and then also right away install an extension. So you can see here on the left, extensions. If I click on that, it shows me what I have installed right now. And there is a Julia language support extension. So you can just search it here. So if I didn't have it, I could just search it and it would bring up a couple of options. And I just like, so this first one is pretty good, I think. And this will help you write good Julia code without any, well, hopefully with as few error messages as possible, and it'll just help you a little bit. I'll show you in a second what exactly it does and how it can help you. So here I've opened my script script underscore one, and then you can see it ends with .jl. And that's just, again, to say this is a Julia script, just so VS Code knows which programming language to use here, because this can work with lots of other programming languages like Python and so on. So just so it knows what to do and how to interpret this code as Julia code. If you make a new file, so a new script, so you can click on File, New File, and then it'll ask you to select a language, and you can start typing and just click on Julia, and you can see the symbol here of this script file change to the 3 Julia dots, so a little Julia symbol. And if I were to save it now, not actually going to save it because I don't need it, but it automatically gave it that JL ending for Julia, and it already called it a Julia script file. So this will make sure that it'll interpret the code correctly. I'm not going to save it because I don't need it, but yeah, when you start a new script file, that's what you have to do, right? So just File, New File, and then select Julia, so it'll save properly. All right. So to actually run a script file, there's this little arrow up here. So top right, don't know if you can see my cursor very well, but top right, it's like a little play button, and you can just execute the active file. And what we have in here, I have a lot more text, but everything is commented out underneath here. So comments are just these hashtag symbols in Julia and many other programming languages. So everything that's being done here is stuff that you already know. So you have 2 variables, and then I'm just adding them up. I'm assigning them to a variable called result, and then I'm going to print the result as well. So I've just clicked on play, basically. So just clicked on run script, and you can see, so this is starting a Julia REPL down here. So you could also work in this, right? So you could also use this as just a REPL, as if you were opening the Julia REPL as usual. But you can see it printed the output of a script here. So it printed 10, which is correct. So something that's helpful in this is that you can hover over the variable name, and it'll tell you what it is, right? So here, doesn't make a lot of sense for this short a script, but if you have a very long script, in the beginning you define something, and then in the end you'll actually use it, you might forget what the variable actually contains. So you can hover over it, and you can have a look of what's in it, right? So that's really helpful. And what you also have is you can hover over a function. So this is print line. I'll show a little more about like print statements in a second, but this is a print line statement. And if you just hover over it with your cursor, it'll give you the documentation. You can scroll through it. So just like in Pluto, there's also kind of integrated help, and that comes from me having installed the extension. So it's helping me. And it's also doing things like, don't know if it works with, yeah, it's trying to kind of auto-complete functions that I might want to use. So that's thanks to this Julia extension. All right, and what you can also do, so you can run the entire script or you can run it line by line. So here I'm running it line by line and I'm just using Control and Enter. And you can see it gives us output kind of both in the script and in the REPL down here, right? So it tells us what's happening. So you can run it line by line if you want to, or you can run the entire thing by clicking here at the top right. Okay, so we have two printing statements. I'm going to uncomment this code just so we can actually use it. All right. So we have print and we have print ln, so print line. So what's actually the difference between the two? If you have print, it won't add a new line after the output, but it'll continue in the same line. And if you have print line, it'll make a new line after this. So if we run the script now, you can see I have this all in the same line. So from here to here, everything's in the same line because there's no new line here after print. But then after hey, I have a new line because I've used print line instead of print here. All right, so that's the difference between print and print line. You can print several things in kind of one command. You just add a comma. So I have my result variable, which was that little addition that we did earlier. And I can use the result is, so just type in text in quotation marks, and then comma, and then result. And then it'll print this line. Right, so I can combine that. And if I want to add line breaks within a print statement, I can do it like that. So I can just add \n. That's just for a new line. And I can do it all in one, kind of like this, or I can do it with these kind of comma separated values, right? You can see it printed line 1 and then went to a new line and printed line 2. So that works. Yeah, both of these work fine. Yeah, but let's look at a couple of issues that you might run into here. So we've seen that in Pluto, you can change the assignment of a variable, or you can create a new variable kind of further down and use it further up. But in a script, you can't do that. Like in a script, it goes through from kind of top to bottom. So variable 3 here in this print statement, I haven't defined yet, right? So variable 2 is 6, but variable 3 I'm defining here. So this is not working, right? So this is telling me undefined variable error, variable 3 not defined. And this error message is trying to help me. So it's trying to tell me, okay, what's going wrong? We don't have the variable defined, variable 3 is not defined. And it's also telling me where the error occurred, because you can imagine, let's say we have a really long script where at the beginning of the script, we're running it, something goes wrong, you get an error message, but where is it, what's happening? So you have these lines here, the lines are numbered. So you can have a look at what line it is at. So that's the last, so 52. So it's telling me here what file, so what script is the problem. If you have several scripts running, then this will be useful to know, like, where is it breaking, where's the mistake. So it's telling me the file with the entire path. This is on GitHub for me. And then the file name, script1, and then line 52. And you can even jump directly to it from here. It's really useful. So I'm holding Control and I'm clicking, and it's jumping into the line that's causing the problem. So if we define it up here, just going to run it like that, and then it's working, right? So that's something to remember for scripts, that you have to kind of do it in order. Okay, are there any questions?
No questions.
Okay. Yeah, so then for reasons of time, I have a little kind of broken script. So this is fix the script JL. This is basically a script that is not going to work. So we're going to run it, and then we're going to try and figure out kind of line by line what the problem is, and we're going to fix it and hopefully make it run kind of all the way through. Okay. And I'm going to just click on this kill terminal for a second, just so that we have a fresh output and that we don't have the output from the old script, but that's kind of starting from fresh. And while this is running, oh yeah, we already have the first error. Okay, so you can try and follow along and see if you can spot. There's a mistake on almost every line, I think. So there's quite a lot to catch here. Okay, so it's giving us an error. It's saying undefined variable error, type of not defined. Okay, so it's in line 8 in this line. Okay, so what we're trying to do here, we have two variables defined, and we're trying to just print that 2 has the type and then whatever type it is, right? Type of. And it's telling us undefined variable error, which is weird. Type of not defined. Type of is a function. So what's going on? We have this underscore that shouldn't be here. So it's type of without an underscore. Okay, so let's see if that fixed it, if that works. So it's thinking that type of is a variable because of this, because it can't find it as a function. So let's run it. Okay, so we have output 2 has the type int64. So that worked, that's fine. All right, but then we get the next error and it's on line 10 here. So here we're trying to say first calculation is number 1 minus number 2, and it's telling us 1 is not a valid function argument name, right? So we're trying to just make another variable here to kind of save the result of this calculation, but it can't start with a number. You can have a number in the middle, but it can't start with 1. So we're changing it to first, kind of spelled out. Okay, let's see. Okay, this is a longer one. Yeah, this is a long, long error message. Okay, no method matching is the error that we're looking at now. So no method matching minus integer and string. Okay, so we try, where is that happening? This is in line 10. So that's this line. So here we have minus, we're trying to do number 1 minus number 2. But one of them is an integer, which is fine, and one of them is a string. And you can't subtract text from a number. And the reason is that we have these quotation marks around 9 up here. This should just be a number. Okay, so we've removed those. So let's see if that works. Did I not click properly? Let's see. Okay, now. All right, and now we have another undefined variable error, calculation not defined. So we just changed this to fix it so that we didn't have it starting with a number, but we forgot to do that in the print statement. Okay. All right, we've fixed that. Okay, and now we have undefined variable error, again, print line not defined. So the correct command is print just ln, right? Not print line spelled out, but just print and ln. All right, good. So we have the result is -7, which is what we wanted to print here. But we're not done yet because the script continues. So here I'm defining a variable, which is my cat, which is her name is Flocke. And then I'm defining introduction. My cat's name is, and I want to combine the two. So I want to combine introduction and my cat's name. So I want to do that with a print. So printing introduction and my cat. And it's telling us here that it has no method matching plus. So for plus, there's no method that lets us use 2 strings. And this is happening because string concatenation needs this asterisk. So not a plus, that doesn't work for strings, it just works for numbers. Okay, and so we have, okay, my cat's name is Flocke. That worked, great, so that fixed it. And then final one, hopefully, is done, exclamation mark, is not defined in line 21. So here we have one final print statement. And looking for a variable because there's no quotation marks around this text, but we just meant it as text. We just want to print some text. So we're doing that, and actually I'm going through and changing every print to print line, just because we have, yeah, it looks much nicer. It's much better to get kind of a sense of what's going on. If you have line breaks, you can see that the error message is like directly tacked onto my output. So I think it's a bit easier to read if we have print line. Okay, yeah, and it runs through without any issues, and we get the output that we want. So we fix this incredibly messy script. Okay, are there any questions?
No questions that I see.
All right, I'll put this is on GitHub. I'll put the solution on GitHub as well in case you feel like having another look. All right, that's it from me. So I'm gonna stop sharing.
Yeah, so I like this, as Julia called it, a very messy script. But if this is your first programming language, you may not realize this may be better named a very typical script where every line has an error and you spend most of the time trying to figure out what you've forgotten or done wrong. Yeah, so we're a little over time, so I'll just wrap it up. Thank you everyone for joining us live. And for those who maybe are going to watch this back on YouTube, we have another meetup coming up soon. I don't have the date off the top of my head, but
2 weeks, I think.
Oh, in 2 weeks already, in the middle of April, where we'll continue looking at types. Specifically, we'll focus on string types. We may also fit some numeric type stuff in there as well, and just keep broadening our understanding of the Julia language. And this will be on
work
YouTube.
On a little project next time as well. So a little project script that you can work along with. So that should be fun. Yeah.
Yeah, great. So follow us on Julia Inclusive on Twitter, or you can follow either me, I think I'm McConnell Kyla, and Julia's Julia Müller FR with MUELLER. You can follow us both on Twitter. You can follow Julia Gender Inclusive, and you can join our meetup group. And we hope to see you live at our next meeting or watching us on YouTube. Yeah.
Thank you.